Hello everyone. The question given is a block of mass m1 shown in figure is fastened to the spring and block of mass m2 is placed against it. Three subparts are given. We will see one by one. The first subpart is find the compression in the spring in the equilibrium position. Now, if you consider the equilibrium position of the blocks, you can consider them as one single block m1 plus m2. The component of the weight of these blocks will be acting in downward direction, which will be is equals to m1 plus m2 into g sin theta. And let us assume that when equilibrium position is attained, the compression in the spring is x naught. So spring will be applying a force in upward direction due to its compression, which will be given as kx naught. And here n will be acting. This n will be balancing other component of the weight, which will be equals to m1 plus m2 into g cos theta. So if you consider along the inclined plane, the upward force kx naught will be equals to the downward force, which will be is equals to m1 plus m2 into g sin theta. So from here you will be getting the compression in the spring when the equilibrium is attained is m1 plus m2 into g sin theta divided by k. Right. Now let us see the second part. The blocks are pushed a further distance 2 by k into m1 plus m2 into g sin theta against the spring. Find the position where the two blocks separated. Now let's just draw the situation given here. Now initially let us assume this is the natural length of the spring. During equilibrium, it was compressed by a distance x naught, which value we have calculated here, x naught value m1 plus m2 into g sin theta by k. We are further pushing it by a distance of 2 into m1 plus m2 into g sin theta by k. 2 into m1 plus m2 into g sin theta by k. So if you compare this pushing which we have done with x naught, that will be equals to 2x naught. So here I can say this is the extreme position up to which we are going. Distance between the extreme position and the mean position is nothing but amplitude. So here this 2x naught is equals to amplitude of this oscillation. Now consider two situations. This is our equilibrium position. Consider the blocks when they are just below the equilibrium position and somewhere above the equilibrium position. First I am taking when the particles are below the equilibrium position. Now I am considering only m2. Here there is m1 block. This m1 block will be applying a normal reaction in upward direction, which I am considering it as n. And weight of the block will be acting in downward direction, which will be is equals to m2 g sin theta, a component of its weight. And we know that acceleration is always towards mean position or equilibrium position. If I assume that these blocks are at a distance x from the mean position, then its acceleration is omega square x. Now if I take the force equation along the inclined plane, you will be getting n minus m2g sin theta is equals to m2 into omega square into x, which implies here n will be is equals to m2 omega square x plus m2g sin theta. Here this is addition of two terms, which is never going to be equal to 0. Blocks will separate implies that the normal reaction between them should be equal to 0. Here it is not possible. Below the equilibrium position, it is not going to be 0. Now let us consider a case when blocks are above the equilibrium position. Here also m1 will be present here. It will be pushing it in upward direction with a normal reaction n. Component of the weight will be acting in downward direction, which will be equal to m2g sin theta. And now the acceleration is always towards equilibrium position or mean position. So acceleration will be down the inclined plane omega square x, if we assume that these blocks are at a distance x from the mean position. Now the force equation will be mg sin theta, m2g sin theta minus n equal to m2 into omega square into x. So here you are having a position where n will be is equals to separation of two terms m2g sin theta minus m2 into omega square into x. So there is a probability that this can become 0 when these two terms are equal to each other. So it is clear that they are going to separate only after crossing the equilibrium position and going above the equilibrium position. Now let us calculate the position where they are going to separate. Now take n is equals to 0, which implies you will be having m2g sin theta is equals to m2 into omega square. Omega for spring block system will be equal to root k by m. So omega square will be equals to k by m. Here m is m1 plus m2 as both the blocks are oscillating together into x. This m2 will get cancelled out, so x will be is equals to m1 plus m2 into g sin theta divided by k. If you see, this value is nothing but equals to this x0 value. So blocks are going to separate from each other when they are going to move a distance x0, which is the compression in at equilibrium position, above the equilibrium position. This is nothing but, if you see the scenario again, this is the natural length of the spring, this is the equilibrium position, this distance is x0. Now blocks are also going to separate at a distance x0 from the equilibrium position, which implies blocks will separate when the spring is coming to its natural length. I will just write it down here. Blocks will separate when the spring comes back to its natural length. Right. Now last part of the question. What is the common speed of the blocks at the time of separation? So we want to find out the speed of the blocks at the time of separation. We know that the relation between v and x, velocity of the block and displacement of the block from the mean position, is given as omega into root of a square minus x square. Now here if you substitute the values, v is equals to omega into, here amplitude is 2x0 minus the displacement of the blocks where it is going to release is x0. So 2x0 square minus x0 square. This will be omega, I am just substituting the values here, let us write it down here. This will be v is equals to omega is root of k by m1 plus m2 into, this is root of 3x0 square. So this will be root 3k by m1 plus m2 into x0. We know the x0 value, which is this. Let us just substitute it here. So here we will be getting v is equals to root of 3k by m1 plus m2 into m1 plus m2 into g sin theta divided by k. So you can see this k will cancel out this k root k times, and this will also cancel out it root m1 plus m2 times. So you can just club it and you can write 3 into m1 plus m2 divided by k into g sin theta. This will be the final answer for the solution. It is a lengthy one. If you want clarity in any of these parts, you can just comment below. Thank you for watching.